Hello students, good evening. So we are in the session 11 of laws of motion. So இன்னைக்கு என்னன்னா we'll already நம்ம session 10ல நம்ம என்ன கவர் பண்ணிருக்கோம், we were looking at the applications of the friction, right? So if you are having the motion of these objects including friction, அது எப்படி வரும், how do we look at the friction force coming into picture and how do we account for the motion including friction, அதுதான் நம்ம already session 10ல நம்ம பார்த்திருக்கோம். இன்னைக்கு என்னன்னா we'll cover two important things. One is how do we understand the circular motion. Understanding circular motion and already nama circular motion patti we have talked about it in the two-dimensional motion la. Okay, but inga enna theriyuma, we will look at circular motion from the requirement of the centripetal force. And whenever we want to have any object to go in a circular path, it requires to have an acceleration towards the center of the circle, which will change the direction of the motion. Okay, so adukena what is the name that we give for the acceleration? Centripetal acceleration dana. So centripetal acceleration has to come from a force. Eppadi and acceleration varum, adukku there should be a force that is acting towards the center of the circle. So how in different examples we will have this centripetal acceleration provided by different type of forces. அது எப்படி வரும்னு சொல்லிட்டு we will look at certain examples and study the circular motion. திருப்பி we will study about the circular motion when we go to work energy and power chapter, and we will also study about the circular motion when we talk about the angular motion. Okay, so circular motion எல்லா topics ஒரே இடத்துல இல்லாம we will try to cover this in different segments. And when we talk about the 2D motion, right, we will be able to understand the velocity or acceleration of the particle which is in circular motion, which is contained in a plane. Okay, ingana theriyuma, we will try to understand the concept of this centripetal acceleration. And when we go to work energy theorem chapter, we will try to understand the circular motion from the work done or the energy change point of view. Okay va. Adukapram when we go to the angular motion, right, adula we will try to do some basic derivations related to the circular motion. Okay, so circular motion பத்தி நம்ம கவர் பண்ண போறோம். அதுக்கப்புறம் we will also look at the idea of the impulse. Okay va. So this is what we are going to cover in the session 11. இப்ப பாருங்க, this is a very common observation, right? Like you would have seen if somebody is tying a stone to a rope, அப்படியே டை பண்ணி if he is rotating the stone in a circular path, it can be a horizontal circle or it can be even a vertical circle. Like நம்ம horizontal circle la அப்படியே நம்ம rotate பண்ணலாம், இல்லனா we can even rotate the stone in the vertical circle. Okay, but whichever circle it is, right, if the stone has to go in a circular path means it requires an acceleration towards the center of the circle. And the acceleration illana, then what happens? The particle will not be able to go in that particular circular path. Adukku already nama value namakku theriyum enadhi, if it has to go in a circular path of radius r with a speed v. Okay, what is the centripetal acceleration required value? V square by r. What is the required centripetal acceleration value? V square by r means the force that is required will be what? What is the force required means mass into acceleration dana, which means we will require a force of how much? M into V square by r. This much amount of force is required. Which direction the force should be acting? Wherever the stone is, the force should be acting always towards the center of the circle. Inga enna theriyuma, what is the force? Paranga, you are tying the stone to the rope and when the stone is rotating in the circular path, right, what is that force that will be acting on the stone which will be always towards the center of the circle? What is it? This is the tension in the rope. So the tension in the rope, right, paranga, tension will be always acting towards the center of the circle dana, which means this tension is going to provide this centripetal acceleration. அதனால the stone is able to go in the circular path. இதுக்கு எப்படி தெரியுமா நம்ம செக் பண்றது? Think about it. If somebody is rotating a stone in the circular path, நீங்க அப்படியே போய் just try to cut the rope. Cut பண்ண என்ன ஆகும்? If you cut the rope, then what is going to happen? The stone will simply fly off. It will fly off along that. எந்த இடத்துல நம்ம கட் பண்ணிருக்கு தெரியுமா? அங்க இருந்து அப்படியே it will go along the tangent. It will not go in the circular path. This is something that we'll see. Even forget about cutting. நீங்க கொஞ்சம் அப்படியே ரிலீஸ் பண்ண என்ன ஆகும்? You are trying to rotate the stone in a circular path. நீங்க ரிலீஸ் பண்ண என்ன ஆகும்? The stone will fly away along the tangent. Okay va? So the centripetal acceleration illena, the particle cannot continue in the circular path. Okay, so this is about the stone tied to a rope, whether it is a horizontal circular path or a vertical circular path. In both the cases, right, what is the force that will provide the necessary centripetal acceleration? Tension. Okay, vertical circular motion patti we will try to discuss about it when we go into the work, energy and power chapter. Adula we will try to discuss about the vertical circular motion of a particle. We will discuss about it in detail. Okay va? Let us think that we are looking only at the horizontal circular motion of the stone. Okay, the vertical circular motion patti we will discuss in detail when we go to the work, energy and power chapter. Okay, so this is one example where we can see the centripetal acceleration is provided by the tension force acting in the string. Okay, so idinala in the centripetal acceleration varudhu, it is coming due to the tension force acting on the stone. This is a very common example. Another paranga, circular turn which is enabled by the friction. Okay, so we see that we take a turn on the road, right? If you look at the turn that you take on the road, it will be like a circular curvature. Okay, so we can see the center here, and we can even look at what is the radius of that circular curvature. So for the time being, the car is actually going in a circular path. Circular path lo ponanna, it will be requiring what? An acceleration towards the center. It will be requiring an acceleration towards the center of the circle. And the acceleration value namak already theriyum. What is it? The required acceleration will be what? V square by r. And the required force, what is the required force? The required force will be equal to what? M into V square by r. M is the mass of the car. If you look at the side view, அப்படியே ஒரு free body diagram மாதிரி, side view of the car, right? பாருங்க, what will be the upward force? It will have a normal reaction. Downward, there will be the weight of the car. Okay, so when you take a horizontal, the horizontal road மேல நீங்க turn எடுத்தா, vertical motion will not be there for the car, which means what? The normal reaction is equal to what? Mg. Normal reaction value will be equal to what? Mg. Okay, now when you look at what is the force that is providing this centripetal acceleration, adana theriyuma, what is the force? It is the static friction between the tires of the car and the road. So what is that force that is providing the centripetal acceleration? What is it? It is a static friction between the tires of the road and the car. Okay, so inga parunga, so you have the contact, the tires of the car and the road will be in contact, right? So inga act agum that static friction, and we know that static friction, right? Static friction, it will have a limiting value. What is the limiting value of the static friction? Mu we are taking as what? Coefficient of static friction. Either we can say mu and solala, or we can say mu s. Okay, so the limiting value of that static friction will be what? Mu into normal reaction. Normal reaction value another mg. So this is the limiting value of static friction. Okay, which means static friction value can be adjusting. It can be adjusting from 0 to this highest value. Adana, because static friction it's a variable friction, self-adjusting friction. Okay, so which means we require this much amount of force to be acting towards the center of the circle. Appada and the circular motion feasible agum. Illana the car cannot take the circular path. Okay, So adukana what is the required condition paranga, this mv square by r, right, should be less than or equal to our limiting value of static friction. What is the required condition for the circular turn to be taken? Adukana what is the condition? The required force, right, should be what? Less than or equal to limiting value of static friction. Ena static friction oda value will be self adjusting, namakku theriyum. It can maximum have how much volume? It can have a maximum value of mu s into mg, right, which means the required force, which is mv square by r, should be less than or equal to the static friction. Inga parunga, mm cancel aidum, on the right side pona it will be what? V square should be less than or equal to mu s into rg, which means what? Inga square root edutha v will be less than or equal to what? Root mu s into rg. Okay, so what is it? The velocity of the car, right, or the speed of the car should be what? Less than or equal to root of mu s into rg. Okay, so this velocity is what we call as the safe velocity or safe speed. Another, we call it as what? Safe velocity or safe speed. So if you are going in a car, if your velocity is satisfying the relation, another, the velocity of the value should be less than or equal to what? Root of mu s into rg. Apdi irundha, then we can safely take the turn. Apdi illanna, what is going to happen if your velocity is high? This is a very common observation. If you are trying to take a turn with a higher speed, appa enna agum? What is it that we observe? Solunga, what is it that we will observe? We will be observing that the car will be skidding away. So in the center of the circle inga irukku vechukonga, car will be skidding away from the center of the circle. Okay, so if the velocity of the car is high, enago, the car skids away from the center of the circle. It will not be skidding towards center. Everybody, like you would have seen, right, when somebody is trying to take a car, turn on the car, turn on the road. If the speed is high, means you will see that, the car will be skidding away from the turn. Why it happens? Why it is always skidding away from the turn? Theriyuma? Paranga, if it is skidding away, means the radius of the circular path is going to increase. So if it is skidding away, means what is going to happen? The radius of the circular path is going to increase. Paranga, if skidding away for some distance, now the new radius of the circular path is capital R. Okay, so capital R value is what? More than smaller. Skidding away from the center means it will be having now a higher radius circular path. Look at this, the mu s into root mu s into radius of the circular path into g, because the radius of the circular path is increasing, right? Adanala this entire term and the term of the value will be increasing. This root mu s into capital R into g will be what? It will be higher than our original value, root mu s into small r into g. So generally, you will see that the car will be skidding for some time, adukaprom it will start moving again. You will be meeting this condition. So initially velocity is higher, velocity is not satisfying this formula. Okay, so velocity is not less than or equal to root mu s into rg, but if the skidding is happening for some time, radius of the value is increasing. So finally you will reach this condition, velocity, right, will be less than or equal to root mu s into capital R into g. The condition meet panadukapram, you will see that the car will again start going in the circular path. Okay, so this is the reason why you will see that the cars will skid for some time if they are coming with high speed. What happens? They will again start moving in the circular path, but the circular path will be now having a higher radius. Okay, so even you would see that if you are sitting in a car, if you are taking a turn, okay, so you would see what? You will also sitting in your seat, you will get a feeling that you are actually drifted away, right? If the friction between you and the surface of the seat and the friction of the value is sufficient, what happens? You will be moving away from the center of the circle. So when you move away, what happens? The radius of the circular path will be increasing. Okay, so what is the condition? The condition is what? the velocity of the vehicle should be less than or equal to what? Root mu s into rg. This is what is the safe speed or safe velocity or formula. So mainly like if you're getting questions on this, means we'll get it from the formula based panni da varum. Okay, so like they might ask what is the safe speed, or they might give us a condition, like they'll say car has to take a turn, it's coming with this much amount of velocity, and the turn is having the radius of curvature value this much, coefficient of static friction is this, will the car be able to take a safe turn or not? So what is it that we have to do? We have to check whether this condition is satisfied or not. What is the condition? The velocity or the value should be less than or equal to root of mu s into r into g. If the condition is satisfied, means safe turn. Illenna what happens? Skidding is going to happen. Okay. Now sometimes when you see the roads, we have taken the road to be what? Horizontal road. We've taken the road to be horizontal, but normally when you look at the turnings, you will see that they will raise the they will lift one side of the road. That is what we generally call as elevation of the road, or in more common language they will call it as banking. And so now what is it called as? Banking. Okay, so this is something that we'll observe. So paranga, in these representations, right, when you're taking a turn, they will lift the road. They will lift the road on one side. Okay, so you can see that if this is the road that is lifted, so this is how it would have been horizontal. Then this is the horizontal, right? This is the elevated road. This is what? Elevated road. Okay, the angle by which it is lifted is called as what? We will call it as angle of banking and so on. What is it called as? Angle of banking. So normally the angle of banking will be having some value. It will not be in this, right, the angle of banking is very high. So almost if you are sitting in the bus, means you will get a feeling as if you are going to tilt down. Okay, but normally you will have angle of banking or value will be reasonable. Because of this banking or elevation of the road, we will be able to have a component of the normal reaction. So because of the banking or elevation, right, we will be able to have a component of the normal reaction to support the centripetal acceleration. Object. So because of the lifting or the banking or elevation of the road, we will be able to have one component of the normal reaction that will support the centripetal acceleration. We will look at this. So this is the horizontal road. We have lifted the road. So this is the modified road surface. What is this angle? This is theta. This is what we are calling as theta. Is what? Theta nadi, angle of banking. Theta nadi, it is what? Angle of banking. Okay. So if you are having a horizontal road, normal vertical. If you just change the road by some angle theta, the normal also will be changing by the same angle theta. So this, we have horizontal surface, we have just lifted it by theta. So the normal reaction, other direction also will be changing by the same value theta. Initially, if our road is horizontal, the normal reaction will be what? Vertical. We have lifted the road by angle theta. The normal reaction also will be tilting by angle, same angle theta. Okay. When we resolve the normal reaction or components, normal reaction tilted. That vertical component because it is making an angle theta with the vertical. So it is making an angle theta with the vertical. So vertical component n cos theta. Upper horizontal component will be n sin theta. This is where your center of the circle is. Okay, so n sin theta is acting along the center of the circle. Okay, n sin theta is acting along the center of the circle. Means this is going to support that centripetal acceleration. The car is taking the turn, but the car does not have any vertical motion. Car is not having vertical motion. Means what? Vertical direction, the force must balance. Downward is mg. Mg should be equal to what? N cos theta. And n sin theta is providing the centripetal acceleration, right? Means what is the force that is required? mv square by r, right? If you want to take a circular turn, means what is the force that is required towards center of the circle? mv square by r. So mv square by r, if it is balanced by, or if it is supported by the component of the normal reaction, we'll have the second equation. What is it? The mv square by r, that will be equal to what? N sin theta. Okay. So here what is the assumption we are making? The component of the normal reaction, horizontal component of the normal reaction, which is n sin theta, is providing the centripetal acceleration. Okay. So let's call it as equation 1, equation 2. We will just divide equation 2 by equation 1. Equation 2 divided by equation 1. So we'll have mv square by r divided by mg. Mm will get cancelled. Is equal to what? Sin theta by cos theta. What is sin theta by cos theta? Tan theta. So tan theta will be equal to what? V square by rg. What is tan theta? V square by rg. Okay. So we will know what is the required angle of banking. So if somebody is saying that the vehicles are coming with this much amount of speed and the radius of curvature is this value, what is the required amount of angle of banking? So what is the formula for that? Theta will be equal to what? Tan inverse of V square by Rg. Theta will be equal to what? Tan inverse of V square by Rg. But once you create a road with banking, right? Once you create a road with banking, the better thing will be you mention, like vehicles are coming on the road, right? You will mention to them saying, this is the safe speed, because the road is already fixed, right? Road will not keep changing its angle of banking. Road is already fixed. So we can mention what is the safe speed to go on that particular road. So what is the relation? Tan theta is equal to what? V square by Rg, right? Means tan theta into Rg is equal to V square. So the V oda value anna root Rg tan theta. Like once you build the road with a particular angle of banking, and you will also have the radius of curvature almost fixed, then you will mention to the vehicles coming on the road what is the safe speed. So if you go with this much amount of speed, right, exactly the normal reaction or the horizontal component, right, will be able to provide the centripetal acceleration so that the car can safely take the turn. So what is the formula for this? Safe speed. What is it? V is equal to what? Root Rg tan theta. V is equal to root Rg tan theta. Okay. So in another we'll have a doubt. What if the velocity is more than this? We are coming in a car which is having a velocity more than this. The required centripetal force value will be increasing. So if you are having a velocity more than this, means what is the required centripetal? This is the required centripetal force, right? Required centripetal force value na mv square by r. If your speed is higher, means the horizontal component of n, which is the n sin theta, will not be able to provide necessary centripetal acceleration. As it is, you will be having the skidding happening. And why? Because the normal reaction of the component is not able to provide the necessary centripetal acceleration. Okay, so if the velocity is this much, what is the velocity exactly? What is the velocity? Root Rg tan theta. The n sin theta value will be able to provide the centripetal acceleration. Okay, so if your velocity is more than the root Rg tan theta, means skidding is going to happen. Okay, so if the velocity is more than root Rg tan theta, means skidding is going to happen. Here also skidding means what? It will be skidding away from the center of the circle. Skidding is always what? Away from the, if you are safe speed, you are having a velocity which is more than safe speed, means the vehicle is going to skid away from the center of the circle. Okay, So this is about the banking which will support the circular turn. Okay, so ella formulas we have to make a note of it. Okay, but normally you will have the road which is lifted, and also it's not like road is perfectly smooth, right? There will be friction between the wheels of the car and the road. So road is having some banking. On top of it, there will be also this friction. So what happens is practically when you look at it, the way they design the roads, both friction will be there as well as the banking concept also will be there. Both will support the vehicles to take safe turn. Okay, so look at this. You are having a road that is already having a banking. So this is what is the banking angle theta. So already the normal reaction will make an angle theta with the vertical. So the vertical component of normal reaction is n cos theta. And the horizontal component of normal reaction it will be n sin theta. Already this n sin theta is what is going to provide the centripetal acceleration when we are just having the banking. But we also have the friction involved. We are also having the friction involved. Is the friction, like in this diagram, right? Represent we have given the friction down this plane madri, because now the road will be like a plane dana. So we have indicated the friction to be like down. If you indicate the friction like this, right? What is going to happen? If you look at, what is this angle? This is 90 minus theta. So this will be theta. Components f cos theta will be towards the center of the circle. F sin theta will be vertically down. So when you have friction acting down the plane, friction provides the centripetal force. Already component of normal reaction towards the center of the circle. You are also having what? A component of friction is also adding. Okay, so which means what? In this case, the friction is also giving a component to support the centripetal acceleration. But it is not going to always happen like this. Friction will not be always going to act down the inclined plane. We have some conditions. If, like the way we have seen in the previous situation, right? If the velocity with which you are taking the turn is exactly equal to root rg tan theta, then the normal reaction of the component, right, that itself will be able to provide the centripetal acceleration. Correct, Dana? So the normal reaction of the component, which is the n sin theta, that itself will be able to provide the centripetal acceleration. So again, the friction itself will not arise, because we are talking about static friction. Static friction will be adjustable. We are talking about the static friction between the wheels of the car and the road. So if the velocity of the vehicle is exactly equal to root rg tan theta, will there be a friction? There will be no friction. There will be no friction. Now, if your velocity is more than root rg tan theta, means what? You are having a speed more than safe speed. The vehicle, so in the circle, center of the circle is this side. We said the vehicle will be trying to skid away from the center of the circle. If your velocity is more than the safe speed, what is going to happen? The vehicle will be trying to skid away from the center of the circle. So the friction will act in the direction opposing it. Opposing means like down the plane. So friction will be acting down the plane when you are having a velocity which is more than the safe speed. When you are having a velocity which is more than the safe speed. Okay, va? Now friction can also act upwards when the velocity, when the friction will be acting upwards when the velocity is less than root rg tan theta. When the velocity is less than root rg tan theta. What do you mean by the velocity less than the root rg tan theta? So here you have the component of the normal reaction n sin theta. if your velocity is less than root rg tan theta means what is it? The required force towards the center of the circle is less. If your velocity, because the required force will depend upon what velocity, then mv square by r. If your velocity is less than root rg tan theta means the required force that is needed towards the center of the circle is what? Lesser. Okay, then what is going to happen? Paranga, you are having a more force acting towards center of the circle, which means the car will try to skid towards the center of the circle. The car will night out to skid towards center of the circle. The car is trying to skid towards center of the circle means friction will try to opposite, right? So friction will be acting exactly in the opposite direction. Friction will be acting up the plane. So here friction will be changing its direction depending upon what is the speed. But idhila namak enga interest theriyuma? So what is it that we are interested in? If friction is also supporting the centripetal acceleration, what is going to happen? We can have a higher velocity for the vehicle and still go in the circular path, right? So we are interested in knowing what is the highest speed. So because now the component of friction as well as the component of the normal reaction, when both are providing the centripetal acceleration, then in that case, right, our safe speed value is going to be what? Highest. When they both are providing the centripetal acceleration, the safe speed value is going to be what? Highest. So we are interested in knowing what is that maximum speed with which we can take a safe turn on the particular road. Okay, so adukku we have some small derivation, and this is we will get a very standard formula. So we should try to remember the formula as it is. Okay, paranga. So this is what we have. We are trying to go with a speed higher than root rg tan theta. We are looking at what is the highest speed we can have so that safe turn is possible. Okay, so like we have seen normal reaction, other vertical component and n cos theta, normal reaction horizontal component n sin theta. Friction paranga, friction and horizontal component another f, so inga oru theta, f cos theta. Friction vertical component f sin theta, vertically downwards irukku. So idhula enna theriyuma, the vertical motion kadiyadu. The car is not having a vertical motion, right? Which means what? N cos theta is equal to what? F sin theta plus mg. N cos theta is equal to what? F sin theta plus mg. Okay. Second, then paranga, the two components, component of friction and the component of normal reaction towards center of the circle, they are providing the centripetal acceleration, right? Means f cos theta plus n sin theta is equal to what? Mv square by r. F cos theta plus n sin theta is equal to what? Mv square by r. We are looking at the value of this velocity to be highest. So the equation solve pandrom, we are trying to look at what is the highest value of v with which the car can take the safe turn. So you are looking to have a highest value for v means the friction also should have the maximum value. The friction should be having the maximum value. What is the maximum value of friction? What is the maximum value of friction? It is the limiting value, right? Which is what? The friction maximum value will be what? Limiting value, which is mu s into normal reaction. What is it? It will be mu s into normal reaction. So paranga, in this equation, right, we will substitute in place of friction both equation 1 and equation 2 we will substitute in place of f, whatever we are going to substitute, mu s into normal reaction. Paranga, first equation becomes what? N cos theta is equal to what? Mu s into normal reaction into sin theta plus mg. Adukapram second equation is what? In place of f, mu s into normal reaction comes. Mu s into normal reaction into cos theta plus n sin theta is equal to what? mv square by r. Okay, so these are the two equations. Okay, if we'll try to just rearrange the we'll call it as equation 3. Equation 3 நம்ம கொஞ்சம் rearrange பண்ணலாம். என்ன தெரியுமா? We'll bring this mu s into n sin theta to the left side. So n cos theta minus mu s into n sin theta is equal to mg. Fourth equation அப்படியே இருக்கட்டும். What is the fourth equation? Mu s into n cos theta plus n sin theta is equal to what? Mv square by r. We will call them as equation 5 and equation 6. So one is almost we got the expression. What are these? Equation 5 and equation 6. We will just do the divisions. Division of equation 6 with equation 5. Other than we are going to get our answer. So the velocity we are going to get from here, right? This is the maximum velocity that is allowed for the safe term. We have taken the friction to be the highest value, limiting value. And we have taken both friction or component as well as normal reaction component adding for providing the centripetal acceleration. Paranga, we are doing what? Equation 6 divided by equation 5 dana. So left hand side mu s into normal reaction into cos theta plus n sin theta divided by n cos theta minus mu s into n into sin theta. This is equal to what? Mv square by r divided by mg. Mn cancel it. Normal reaction cancel it. Numerator and denominator. So what we are going to get? Mu s cos theta plus sin theta divided by cos theta minus mu s into sin theta. This is equal to v square by rg. We'll divide left hand side la, we'll divide numerator and denominator by cos theta. Cos theta which it we'll divide it. Cos theta. Cos theta. Cos theta. Cos theta by cos theta is 1. Sin theta by cos theta means tan theta. So mu s plus tan theta divided by cos theta by cos theta means 1. Sin theta by cos theta means tan theta. 1 minus mu s tan theta. Mu s plus tan theta by 1 minus mu s tan theta is equal to what? V square by rg. Okay, so which means V square is equal to what? Appadi and the rg left side level. We are going to get this rg value to the left side. Okay, left side what is it going to be? Rg into what is it? The value of V square will be what? Rg into mu s plus tan theta divided by 1 minus mu s into tan theta. What is it? V square value, right? The value of V square is what? V square will be coming as what? Rg into mu s plus tan theta by 1 minus mu s into tan theta. Okay, so then the V will be what? Root of Rg into mu s plus tan theta by 1 minus mu s into tan theta. This is a standard formula. So this is what? The safe speed. And this is the safe speed. So this is the maximum speed you can have while going on a car on this particular road. Both the banking is supporting the circular motion as well as the component of the friction. Okay, va? Even I think I think in 2014 or 15 or in the as it is formula they have asked the formula itself, the maximum safe speed for taking a circular turn where both the friction as well as the component of the normal reaction supports. Again, what is the formula? V max is equal to what? Root of Rg into mu s plus tan theta nu sollala, or we can say tan theta plus mu s, whichever it is. Okay, so tan theta plus mu s divided by 1 minus mu s into tan theta. Okay, so this is the maximum speed that you can go in a car and take a turn, safe speed. So idhil both the component of friction as well as the normal reaction component, both are supporting the circular turn. Idhukku or practical observation enna theriyuma, like you would see people riding on that cycle. The cycle turn edukumbodhu, what is it that you will see? They will appadiye upright ah irundittu, they will not take the turn. Enna பண்ணுவான்? They will be trying to bend the cycle in one way. Edukku, why they are bending? Think about it. Bend panna, you will have the normal reaction like this. Means what? There will be a normal reaction on a component varum that will support in providing the centripetal acceleration. And the madri there will be also friction. So why you see people trying to bend the cycle while taking the turn? Because apdi bend panna, what is going to happen? Whether the road is having a bank or not, road may or may not be always banked. So when you bend the cycle enna agum, you are automatically providing a component of the normal reaction to support the centripetal acceleration. Okay, wow. So this is one of the practical observations that we do. Understand why people actually bend the cycle while taking the turn. Okay, and eppadi theriyuma, when if you are taking the turn to the left side, means you will bend it to the left. Nobody will be bending it to the right side. Okay, clear? So this is one of the practical observation that we see people trying to help by providing a component of the normal reaction to support the circular turn. I'm sure if you go to these exhibitions and all these things, right, you will see these death well and solite. You will see that the people either on the scooter or whatever the bike, they will be keep on going. How they will be like that well is like this, right? It's like a well. How they will be flat. The vehicles, right, will be flat, and you will see people whoever is liking that they will even give them the money. Apadi kudutha, they will, while riding the bike itself, they will take their money and even put it in their pocket. Okay, but idhil enna theriyuma, we want to understand what is the physics behind it. I'm sure neenga the exhibition pona as a child, right, you would be wondering how they are able to just go like that, why they are not falling down. Edukku theriyuma parunga, if this is how they are like this, they are actually going in a circular path. This is the death well, right? Okay, so they are in a circular path, and circular path will be a horizontal circle. Circular path eppadi irukum? Horizontal circle. The normal reaction, right, normal reaction, like if the person is here, means normal reaction is providing the centripetal acceleration, which means the normal reaction value is equal to what? Mv square by r. Normal reaction value is what? Mv square by r. Inga parunga, when the person is on the bike is flat, bike mattum kadiyadu, you will see even some of the places, right, they will even go in a car also. They will have their weight. The weight will be always acting downwards dana, and they will be tending to go down because of the weight. What will oppose friction? Parunga. So then friction will be what? So if the weight is acting downwards, means friction will be acting upwards, opposing dana. So here, for the people to go safely in the death well, right, adukana what is the condition? The mg oda value, right, mg value should be less than or equal to the limiting value of the frictional force. Mg oda value should be less than or equal to limiting value of friction force. What is the limiting value of frictional force? Mu s into normal reaction dana. Mu s into normal reaction value anna mv square by r. So idhula mm cancel aadu. So neenga parunga, what is it? G should be less than or equal to what? Mu s into v square by r. So adilende gr by mu s should be less than or equal to v square, which means we can write it like this also. Eppadi? V square should be more than or equal to gr by mu s, or we can say v should be more than or equal to root gr by mu s. So here our velocity safe speed, right, is not having, normally when we talk about the safe speed, we will talk about what is the highest speed you can have. But idhila appadi kediyadhu parunga, idhila enadhi, the velocity should be more than or equal to root gr by mu s. அப்படி இருந்தா என்ன ஆகும்? If the velocity is increasing means what? Normal reaction value will increase, so static friction or limiting value will increase. So thereby, the static friction will be able to oppose the weight. Okay, so here the safe speed, right, is not having a limiting value as we always have the velocity to be safe speed, and so now we will say what? The velocity cannot be more than that. But the velocity has to be more than or equal to root gr by mu s. Then the frictional force will be able to balance the weight. Then what is the frictional force we are talking about? Static friction. Static friction will be able to balance the weight so that the people can safely go in the horizontal circle. And vertical direction force into balance side, then the person will be able to go safely in the horizontal circular path. If for some reason avangala vehicle stuck ayiduchena, what they are going to do? They will not just be staying there, they will just spiral downwards. Apadi pannalanna what happens? When that velocity is decreasing, right? If the velocity is decreasing means normal reaction decreases, because normal reaction is what? mv square by r, right? Velocity decreasing means normal reaction decreases. Normal reaction decreasing means friction decreases. So you will reach a stage where the mg will be more than friction, means the person will fall down. So whenever they have an issue with the engine or something, right, you will see that even when they are going down, how they will go down? They will be spiraling up, they will spiral downwards. Okay, so this is about the physics behind the death well. So here they need to have what is the safe speed. What is the safe speed? What is it? V should be more than or equal to root gr by mu s. Okay, this is the safe speed formula. If they don't have this much velocity means they will fall down. Okay, அடுத்து என்ன தெரியுமா? When you are going on a horizontal road, or you will be getting a bump. The bump is basically a part of the road. It may be like a convex bump, and you can even say like a bridge. It may be a convex bridge or it can be a concave. Okay, so bump you call it as what? Convex. You call it as what? Concave. Okay, so when you get into this convex bridge, then look at it practically. When you go onto that convex bridge you will get a feeling that you are feeling lesser weight. We'll look at it. Okay, paranga. So if you are going onto that convex bridge, look at this, you will have a weight and normal reaction. Center of the circle down, means net downward force, which is what? mg minus n1, that is equal to what? mv square by r. And the center of the circle is downward, right? So we have to look at what is the net force towards center of the circle. Adanadi mg is down, normal reaction is up. So mg minus n1 is equal to what? mv square by r. We are looking for the normal reaction, right? Appadi nama rearrange pannalam. What you are going to get? mg minus mv square by r is equal to n1. Paranga, what is the normal reaction here? Less than mg. Normal reaction is what? Less than mg dana. So generally what is our normal reaction? Mg. So there we will see our true weight. But in the normal reaction is decreasing, it is less than mg, so you will start feeling that you are getting lesser weight. In one situation, when you are getting onto this concave type of second situation, when you are getting onto the concave type of a bridge. Concave bridge what is it that you are going to observe? Paranga, here the so this is a concave shape. Center inga varum. Paranga, we have to look at net force towards the center of the circle dana, which means net force we should see upwards. So upward force is N2 minus downward force is mg. This is what net force towards the center of the circle. Okay, va? So N2 minus mg is equal to what? mv square by r. Okay, so what is the N2 value? N2 will be up on the minus mg right side, it will become what? Plus mg dana. So it will be what? mg plus mv square. Paranga. One arm reaction is what? More than the mg value. So you will go on to the concave type of bridge, means you will feel that your weight is what? Higher. Why is it happening like that? Because you will only see the normal reaction. Weight and so now what is that you feel? You will feel the normal reaction. Okay, your weight as such is going to be what? Force acting on you because of gravity, which is not going to change. Your weight is not going to change, but what you perceive is what we all will perceive. We don't perceive our true weight. We will all be perceiving what? The normal reaction acting on it. So if you're standing on a car or something, if you're standing on something, you will always perceive the normal reaction acting on you as the weight. Okay, va? So this is about the feeling or the observation we have in terms of the perceived weight. Now another thing is this conical pendulum. Okay, so this we discuss when we go to the oscillation chapter. Conical pendulum, think about it. You have a same stone patti pesirukku theriyuma andha madriye, but idhula enna you will have the object tied to the rope going in a circle. And the overall shape ninga paatha it will appear like what? A cone madri varum. Okay, so this is the rope. This is the rope to which you have tied the stone. Stone. So you are trying to rotate the stone, and the stone will go in a circular path only. Stone will be going in the circular path. Okay, but in the rope would observe panna, it will look like what? It is creating a cone type. That is why we call it as what? Conical pendulum. We will just look at what is the centripetal acceleration. So how the centripetal acceleration is coming? Paranga, the tension in the rope, right? And the object mela. So this is the object. Object. This is the point to which we are tying. Okay, va? So the object will have its weight mg down, tension will be into the rope theta, which means theta will come here. So components t cos theta up, t sin theta horizontal. So force balance vertically motion kadiyadu, which means force balance dana. So mg is equal to what? T cos theta. Horizontal ஒரே component இருக்கு, என்னது? t sin theta மட்டும், which means the centripetal acceleration என்னது? mv square by r will be provided by the horizontal component of the t, tension. And tension of the horizontal component provides the centripetal acceleration. So adukku enna, what is the relation? mv square by r is equal to t sin theta. So paranga equation 1 equation 2 and solla. Divide equation 2 with equation 1. Left hand side la mv square by r divided by mg. Right hand side la t sin theta by t cos theta. Paranga t cancel aidum, idhula mm cancel aidum. So v square by rg is equal to tan theta is the relation. Okay, so for a object going in a conical pendulum motion, right? And what is the relation we have? V square by rg value is equal to what? Tan theta. So we will discuss about it when we go to the oscillation chapter. Okay, so these are some of the examples of the circular motion and how the centripetal acceleration is provided by the various types of forces. Okay, other than an impulse. Okay, it's a very simple concept, like when you are putting some nails into a wood or wall. It's a very common observation. You will take the hammer, you will go and hit the nail for very small time. Like you will not see that, okay, person is slowly going and hitting the nail, right? What you do, you will just hit the nail, you will just pull the hammer back. Why you are doing it? I think there should be reason, right? Then you will not see the impact coming maximum. So what is the common observation whenever you are putting some nails into that wood or the wall, right? What is it that you will do? You will hit the nail with the hammer, and you make sure that the contact time is less. You will make sure that the contact time is less. You are having the hammer. Let's say hammer or mass is m. It's having a velocity v. So the initial momentum, hammer or initial momentum, m into v. Final momentum, once it is hitting the nail, it will finally come to rest. Dana. So final momentum is 0. So change in momentum. Change in momentum now, final momentum minus initial momentum. The very magnitude mattum paakala. We'll just look at the magnitude. So what is the magnitude of change in momentum mv? Remember, for any object, right, the force acting on the object, what is it? Rate of change of momentum. What is the force acting on the object? Rate of change of momentum, which means on the hammer or change in momentum in the mv, divide by, we are keeping t as the contact time. So when the momentum is changing, once you hit the nail, whatever the time it is in contact, right? So the change in momentum is happening for the time. So the rate of change of momentum means change in momentum divided by the time. Paranga, this is the force acting on the hammer. But Newton's third law concept, right? If hammer is experiencing a force, it is because of the nail, which means nail will also experience the same amount of force, but in opposite direction. So paranga, the force, impact force acting on the nail. What is the impact force acting on the nail? What is it? It will be having the same value, magnitude wise same. Now what is our purpose? We want to push the nail into that wooden object, means we want to have the impact force to be maximum. What is the thing that we can do? Because how much velocity we can bring the hammer, it depends upon what is the energy we can spend. With how much velocity we can bring the hammer is somebody who's like very muscular, right? They will be able to bring the hammer with a very high velocity. If you are having a lesser strength, means you cannot give it so much velocity. But we can increase the impact force by reducing the contact time. The hammer nail or contact time reduce panna, what is going to happen? The impact force will be increasing. So adanala you will try to hammer the nail by making sure that the contact time is less. Then what you are going to achieve? You will be achieving a higher impact force. Okay. But exactly opposite example, there will be some cases where we want to reduce the impact force. Like when you are catching a cricket ball or any object. So in the example, you have the cricket ball, which is say for example having a mass and coming with a velocity v. So what is the initial momentum of the cricket ball? M into v. Catch complete panadukaprom, what is the final momentum? The final momentum is 0 dana. Okay. Now magnitude of change in momentum. Change in momentum will be minus mv, but magnitude which is mv. So what is the force acting on the ball? The change in momentum by the time. So T is what? The contact time. So whatever is the force acting on the ball, right? Force acting on the cricketer also will be same, but exactly opposite direction. Okay, but Newton's third law says what? Action reaction pair, right? Force acting on the cricketer will be what? mv by t. Observe pannunga, when you are actually, if you are somebody who has played the cricket, like when you're doing the catch practice, right? What is it that or basic rule when you're catching a ball, you will actually drag the ball and so like you will catch the ball, you will have to drag the ball. like, you know, wicket keeper or anybody who is taking the catch, they'll see once the ball touches your hands, right, you will actually drag the ball for some time. When you drag the ball for some time, you know what is going to happen? The contact time will be increasing. In this we are going to see exactly opposite objective. In the hammer case, we want to have a higher impact force, but you don't want to have higher impact on your hands, right? Because if that is happening, what happens? After taking some 3-4 catches, your hands will start paining. So you try to minimize the impact. You will try to increase the contact time. So generally when you take the catch and you drag the hands, right, so you are keeping the contact for longer time. You're keeping the contact for longer time. So the contact time is increasing. When the contact time is increasing, the impact force will be decreasing. When the contact time is increasing, right, the impact force will be decreasing. Okay, so this is one of the practical applications where we are having exactly opposite objective. Okay, so in one case we want to have a higher impact force. We are trying to have a lower impact force. Okay, so with this we'll stop in today's session, and next session we will continue about the discussion on impulse. We also have to cover about the rocket propulsion. Okay, so otherwise we will try to wind up the laws of motion chapter. So maximum next session we will be able to cover this. Okay, so practice some questions. We will see in the next class.